In this video, we will demonstrate Kato's secure and optimized SD-WAN capabilities. We are now looking at our demo environment. It will provide a visual context for our capabilities. Kato enables companies to expand their WAN capacity and flexibility by deploying different transport services to meet location requirements. Transports include MPLS, Internet links, and 4G LTE. Our demo environment has two locations: a remote office in Washington, D.C., and a data center in Frankfurt, Germany. Each site has a Kato socket with two links, one to the MPLS network and the other to the Internet. The sockets connect across the Internet to the nearest Kato POP. The Washington office connects to our POP in Ashburn, Virginia, and the Frankfurt data center connects to our POP in Frankfurt. Our demo environment is part of a larger enterprise network with 27 remote offices and physical and cloud data centers. As you can see on the Kato management screen, all sites are connected to Kato's cloud-based network. From here, you can view the overall network activity, configure policies, and manage the entire network. Let's drill down to one of our SD-WAN demo sites and review the configuration. You can see the links connected to the Kato socket. WAN 1 is the Internet link, and WAN 2 is the MPLS link. The SD-WAN policy is configured globally across sites and can be overridden per site if necessary. Our policy-based routing sends voice and video traffic via the MPLS link. Files and data are sent via the Kato cloud. In cases when demand exceeds MPLS link capacity, traffic will be automatically routed through the Kato cloud and its SLA-backed backbone. Let's see policy-based routing in action. In this example, the user plays the video and downloads a large file over FTP at the same time. On the Network Analytics dashboard, we can see that Kato utilizes both links and, based on the policy, routes the video over the MPLS, the blue line, and the file download over Kato, the green line. Now let's see how Kato responds to a network outage. The user plays the video again. Traffic is routed via the MPLS link based on our policy. Now we will crash the MPLS session by dropping the link. Our MPLS line goes red, showing that there's been a line failure, yet the video continues to play. The user experience isn't disrupted since the traffic automatically moved onto the Kato cloud network. Now let's bring the MPLS line back up. Our MPLS line turns green, and since our policy prefers to route video over MPLS, the traffic moves back from Kato to MPLS. Again, without any impact on the user experience. All of this is shown in the Kato management application. We see that the traffic started going over MPLS, represented by the blue line. When we dropped the MPLS, line traffic moved over to the Kato cloud, the green line. Traffic moved back to the MPLS line when it was available again. We've seen how Kato directs traffic to the best available network, and we've seen what happens when a network fails. But what happens when there's simply congestion on the network? How does Kato respond then? Let's take a look. Here, we're placing excess load on the network. The user now plays two videos. The first one starts, and traffic is routed via the MPLS link based on our policy. When the second video starts, due to MPLS bandwidth constraints, the line gets congested and turns orange. Kato now moves the additional video traffic to the Kato cloud network. Again, the user experience isn't impacted, and both videos keep playing smoothly. Once again, the Kato dashboard shows the traffic split between the two links. The next part of our demo will show Kato's built-in network security capabilities. We'll start by showing how URL filtering policy is managed and the user experience when accessing risky or unauthorized sites. The URL filtering provides out-of-the-box categories and recommended policies. For example, our policy for gambling sites is to block access. When the user attempts to browse to a gambling site, Kato will block the attempt and redirect the user to a page with detailed explanations of the company policy. Now, let's see what happens when a user attempts to download a malicious file from the Internet over TLS. Kato inspects all traffic for malicious content. The download attempt is blocked, and the user is notified. Kato runs its integrated anti-malware inspection on all traffic, both WAN and Internet, as seen in this configuration. The last part of our demo will show how Kato secures access to public clouds, starting with Salesforce. To prevent unauthorized access and protect against credential theft, Kato provides a unique feature that allows customers to configure their SaaS applications to accept traffic only from the Kato Cloud-specific IP range. Users connected to the Kato Cloud log into Salesforce as usual, but others trying to access Salesforce directly outside of the Kato Cloud will be blocked. We were able to do this by allocating a unique IP address to each customer. The customer can then set specific application traffic to exit the Kato Cloud for Salesforce only via that unique IP address. As such, company users with a different source IP address are blocked from accessing the application. Since Kato's POPs are located in the same data center as the leading cloud application providers, such as Office 365 and Amazon Web Services, Kato can optimize routing and minimize latency regardless of a user's locations. In this example, a user in the Washington office needs to reach his Office 365 instance in Frankfurt. Normally, the user would send traffic across the internet and incur the long delays typical of transatlantic internet connections. With Kato, the user's traffic is identified as Office 365 traffic and automatically routed to the nearest Kato POP, and from there, they enjoy the low latency of the Kato backbone. This was a short demo of Kato's secure SD-WAN capabilities. Contact us through our website to try Kato in your business. Thank you. Kato Networks. Network and security is simple again.